Hello. Hi. How are you? Hi guys. How are you? So today we are going to start a very new lesson called heat and thermodynamics. In the other way, it has a name called thermal physics. Thermal physics part. Shall we see what is that thermal physics included? So, open a very big topic that is called heat. Oh, good thermal physics. Heat. Oh, thermal physics. Thermal physics. So I have to tell you some very important things related to this lesson before starting to teach. So this lesson almost will carry certain percentage of marks, somewhere from 17.5 to 19.5 marks in an year. So this is the second most lucrative lesson to earn more. Nearly around 20% of the mark is from this one lesson. I will tell you how it is. So you know the paper one consists 50 MCQ. Out of this 50 MCQ, it will just give you 50% of the mark for one MCQ per 1 mark per 1 MCQ. So out of here, there will be 5 to 7 MCQ from heat. 5 to 7 MCQ are from heat lesson. Okay. So you know the mark count, it will be 5 or 7. Now in the second part, paper number 2A, there will be a definite what? Structure question. Definite structure. So that structure will carry you some 5 marks out of percentage, 100. There will be 5 marks. And also out of, they say like, they take the marks like out of 50 from the first paper, they take mark out of 200 for the second paper. Out of this 200, it is 80. You divide this 200 again by 4. So your final mark count will be 24 whole structure. Then this will be 50. So out of that 50, you have a 5 mark from this structure question. Apart from that, in the second paper, there is a definite essay question that carries some 7.5 marks. Altogether, it will be somewhere like 17.5 or 19.5 marks. Understand? So this is going to be pretty much of important, very important lesson. Absolutely important. Okay, the other thing. So my students normally never do heat in the essay question because I teach matter and radiation in 200% accurately. Even this one is, but these questions are really longer because the syllabus is very long here. But in matter and radiation, it is a 2-day lesson. Within that 2 day, I teach every nooks and corner in the subject. So most of the time, my students do MR, that is not Mahinda Rajapaksa, matter and radiation, definitely, but very rarely they do it as well. You can do. I complete this lesson with all the proficiency, but getting full mark for math and radiation is easier because you have an option. In the normally the last question, 10th one, A is from heat, part B from matter and radiation. So mostly matter and radiation is really hard. They consider most of the students don't touch it even. But here it is a different story. You will understand once we done. My students normally do matter and radiation before any of the other questions. So there are some students, they say, sir, I did matter and radiation first. Actually, you can do in any order. It doesn't matter. You can start up with the last question at first. There, most of them do matter and radiation first. Okay, somehow. So this is the way how the marks are distributed. Firstly, there are 5 MCQs, 5 to 7 MCQs, 5 minimum. 7 is the maximum. The structure, there is a 5 mark. Here 7.5, 5 and 7.5, 12.5, and 5, 17.5. If 2 more MCQs come, nearly we can expect like 19.5 marks out of all 100 marks of the paper. It make a really high valuable lesson. So I expect you guys to do really well in this manner. So now just write a very big topic, heat or thermal physics. We are going to learn the future stuff of the lesson in terms of like the topics. You have to search some of these and get to know we did this one, we did this one, like that. There are 9 subtopics in this part. How many? 9 subtopics in this part and 9 practicals also. So most of the practical count coming in this lesson than mechanics even. So most of practical count, really 9 subtopics, major subtopics are there. So now write this in a new line. There are 9 subtopics in heat lesson. Okay. What is the first one? First one is thermometry. First one is what? Thermometry. Thermometry. Number 1. Thermometry. It is a single word. Accidentally, it got detached. This is a single word. Thermometry. Okay. Thermometry. The next one is expansion of solids. Expansion of solids. I will only write ES. Expansion of solids. Next part, expansion of liquids. The next part, expansion of gases. For chemistry students, it's an advantage because they learn it for the second time. In physics class, they normally learn this thing in chemistry, in physical chemistry part. If you are a chemistry student, let me know whether you have completed that gas laws, Boyle law, Charles law, combined gas law, those things. Yes or no? Huh? Have you completed? Wow. Completed. You will see the same thing, but in physics application, in that one you learned in chemistry application. Here you are going to learn in physics applications. Okay. Now the next is the question number 5. Sorry, topic number 5. Yes, and the calorimetry. Calorimetry, CM. In India, if you have watched mostly Tamil movies, they always calling of CM and CM and CM. That is about calorimetry, and calorimetry, no. Central Minister. Mohammed. Okay. Then telemetry. After that, thermal conduction. TC. Take care. Kakekare. Thermal conduction. The next part is thermal convection. Oh yeah. Wow. If it is thermal conduction, if it is next one is thermal convection, what is the next one? Thermal? Can you tell me? With your knowledge.
Radiation.
Thinking like thermal radiation, no? No. Thermal radiation is under matter and radiation, it will be a different lesson. Again, I write MR, MR ලියන්න කැමති නෑ. නිකන් මහින්ද රාජපක්ෂ වගේ වෙනවා. ඒක මගේ ආසයි. Convection, thermal conduction, thermal convection. Next part is, sorry, with mark 8. Right. Vapor and hygrometry, or just write humidity, vapor and humidity, or vapor and hygrometry. Hygrometry. Hydronymy, hygrometry. The last subtopic is vapor. This one is thermodynamics. මං ආසම කෑල්ල. ළමයි බයම කෑල්ල. මගේ නම් favorite. Thermodynamics. උදේ ලකුණු තියෙනවා 17.5 to 19.5. මම කියනවා ඔකෙන් අපිට 12.5 එහෙම නැත්නම් 10.5 මේකෙන් ගන්න ඉතුරු 7.5 මෙයාගෙන් ගන්න කියලා. හැබැයි ඔක්කොම කම්ප්ලීට් කරනවා. ඔයා වැඩියෙන්ම දක්ෂ හීට් වලට නම් what heat? Can you send me that message again? Sarina? Expansion of solids, expansion of liquids, expansion of gases, calorimetry, thermal conduction, thermal convection, vapor and hygrometry, thermodynamics. So technically, what the heck? Technically, we will have to spend 1 week for each. 1 week. So nearly 9 weeks, that means 2 months. 2 whole months. Oh yeah. Now the problem is we are in the end of what? March. April and May. You were right. June, July, August, September, October, November. We have only 6 months after that. So it is not really going to be user friendly and advisable. So now it is time for you to bless your engines, so your engine capacity, and work really hard. And I have to tell you one important thing. I tell you, you cheat. You definitely cheat. Why? Whenever you are about to study, you always cheat yourself. Don't you? If I ask you, don't you? Yes or no? Tell me, you cheat. All the students I used to know, even very high achievers, they used to cheat. ඔයාලා cheat කරනවද නැද්ද කියලා කියන්න බෑ. Huh? Realize it midway. No, you cheat. The reason is you always pick up the easiest subject for you at the beginning of study. Lazy subject. So imagine like if you are a bio student, bio, physics and chemistry, maths, physics and chemistry, maths, physics and IT. Whatever the combination you do, you always choose the easiest one first. In that subject even, easiest subtopics, easiest chapters, you choose and study. So when you feel really sleepy only, you realize, oh, I didn't study. Imagine like you really love chemistry, you do chemistry today. In the next day, also chemistry, physics, hardest. Then you only take it. Oh my God, I forgot. Then you just read few chapters, you fell asleep, and your mom comes and that's it all over. ඕක තමයි වෙන්නේ. Now, sometimes in my students, they say like, sir, physics is my easiest, physics is my most favorite subject. That's good, I like it. But the problem is, if you don't do biology well, if you don't do chemistry well, so that's a problem. So passing a certain one subject in a really high mark will never campus එකේ assignment කරන්නෙත් එහෙම සලුව එකෙක් කියනවා campus එක යන ගමන් එන එක. ඉතින් හිතන්නකෝ. That's human mindset. Yes, it's the cognitive ability, one of the thing, but you might have heard of one thing. ETF. ETF. What is ETF? CLI එහෙම කොහෙද කියනවනේ මේ ETF, EPF. Employees Trust Fund something. Oh, is that extended tree frog? Whatever. Yeah. Extended tree frog. Oh, whatever. But the thing is, ETF is our mindset. What is it? Easy thing first. Okay, ලංකාවේ මිනිස්සු ETF EPF ගැන මොකද කරන්නේ? ඒකම තමයි. Easy thing first. Actually, this is a good sign. But if you use really kind of like what? Right time, right thing, right way. But in most time, you just dig your own grave. It's very bad. So the thing is, easy thing first rather than that. So whenever I eat, I am a really foodie guy. If there are like A, B, C, three different foods, and if I like all three foods, and one food is not that tasty, A is low tasty. Tastiness is not that much. Okay, now B is tastiest. This one is somewhat tasty. Normally I eat A first, then C, finally I eat the most delightful one. Because if I do the other way, tastiest, next tastiest, yuckiest. Wow. කෑවා කියලා මතකත් නෑ අවුලෙන් ඉන්න දෙන්න. So that's the way I do hard is venerable. And say HIV hard is venerable. So there is a cricketer in Indian team. The commentators pronounce his name in a weird way, but his name is Hardik Pandya. Now think how the commentators pronounce it. I don't say that. Hardik Pandya. They pronounce it in a certain weird way. As you said, you love him. Oh, you always love uncles. Okay. Hardik Pandya. So they pronounce it in a weird way. I can't pronounce it. Somehow, as you said, HIV hard is vulnerable, like that. Hard comes in that name even. So by the way, here we see. But I eat the lowest taste one, next taste one, tastier one in the list. Why? නැත්තම් කටත් එක්ක සවුත් වෙලා යනවා. So whenever you study, start with the hardest one because you are really fresh at the time. You had a shower, you just ate something, and your energy level is very high. Your brain is probably functioning. Just start with the hardest. Do some amount of work. Do even harder. Then touch the next one. Finish up whenever you feel really sleepy. Finish up with whatever the thing you feel really satisfiable. Easiest lesson in the sleepy time. That will be fantastic. Marvelous. Another. So this is how you have to do. Somehow you have to have a really good study habit. Otherwise you will have to suffer. So I will do something like this. Thermometry today. Nothing else, because thermometry and small part of calorimetry I bring forward because of one reason. Can you remember I did circular motion before? And circular motion I did. Then I went to do like what? Sorry. What is it? Hydrodynamic first, then circular motion, again hydrostatic, circular motion, hydrodynamic, and rotational motion. That's how I strap, because to make you comfortable. But most of the students didn't find it easier. Because they worship to the physical one like this and getting a really big result. So by the way, I just bring another brave effort, calorimetry, a bit. There is a reason, because you may need proper sufficient time to get adapted to these terms. මොකද මේ ටික ටිකක් වලට සෙල්ලම් කරන්න දුන්නේ නැත්තම් මෙයා හිටෙද්දී එක පාට දුන්නාම අවුට් වෙලා යනවා. All these lessons you need that. All these parts you need that parts. That's why my methods are like not hard. I am always believing one thing: work smart, not hard. So you have to be smart. So today, whole day will be spending on this one, but in the next day, I will do solids and liquids all together in the second day. Third day, I will badly need whole day for gases. Third day, 4 lessons completed. Then after that, I can happily do calorimetry and thermal conduction in a one day, no problem. So now thermal convection and some part of vapor. Some part of vapor can be done in the 5th day, and in the last day it will need one day, 6th. So I am going to restrict 9 days to 6 days. So it is going to be, we are only spending 66% of the time regular time frame is should be, because I have a specific plan. Don't worry, we can definitely do this plan. After that, you know my real method. I will spend another 2 days to practice really high amount of questions, including heat, as well as waves, as well as optics, as well as mechanics. මේ සෙට් එකෙන් මදාපු හොඳ quality questions අපි දෙකක් කරලා ඊට පස්සේ decide කරමු in the next 6 months what to do. Can be starting with mostly electrostatic. So we can just definitely manage everything by next later 6 months, because those lessons are not really long, very short lessons. So typically that's it. Shall we start? Say yes.
Okay.
Hmm. Okay, guys. Now write a big topic, temperature. 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 Can you tell me what is temperature? Definition of temperature? Can anybody tell me the definition of temperature? Any idea about temperature? Huh? Any idea
It's a
about
physical
temperature?
quantity that provides an idea
Huh?
about the heat energy that is absorbed by a certain body.
You said something I couldn't hear. Say that again, boy.
Can we define it as a physical quantity that gives an idea about the amount of heat energy that is absorbed by a given body?
Yes. Good. And other, I have to tell you one thing that's to disappoint you. There's no proper definition for temperature because temperature is one of the 7 physical quantities. So basic physical quantities, you have no specific definition. කිසිම එකකට නෑ. Length, time, mass, ඔය කිසි දෙයකට there is no proper definition because they are the basic. You can't define it using other quantities. Neither. You have to use these quantities to define others, but other quantities you can't use to define the basics. So this is just a basic physical quantity. You can't define it from others. Okay, there is no definition, but we can write it like the following, not a definition, just write temperature is a certain sensation of how hot or cold. How hot or cold. We used to say, wow, this is so hot. Not that hot. And we also used to call, wow, that girl is too cool. Girls also say the same thing to us as well. Oh my god, that bag is so dull. Dull the cool the කියන එක ඔයාලා තමයි decide කරන්න. It all depending on with your own behavior. 37 Celsius hot. Okay. So I remember one thing in my physical class. In my physical class, there is a guy called Akash. I know that guy has a strong crush on a girl called Aishwarya, Tamil one. So I just used to kind of like tease him. Akash, මොකෝ වෙන්නේ? Aishwarya දාවේ නේ? දුකෙන් දෙන්නේ. Like that. Then finally, one day I said, hey Akash, Aishwarya Mara hot ne. So කියන්න පාස, she's not a temperature. She's a beautiful girl. උඩ ඉතර වැදිලා මාර විදියට. මම නෝන්ටියක් දැම්මා කොල්ලට. And then in the next day, Aishwarya came. Then I said, Aishwarya, are you temperature or a beautiful girl? Then she asked, why, sir? No, for some reason. අරු වරේන කෑගම්. No. මරු හතල් එකක් දුන්නේද? මේ සාස් ඔයම වඩ ෆිසිකල් ලවුනා නම් එහෙම නැති කරන්න තිබුණා. නේ සාස්? It went really well කිව්වනේ. සාස් boy, where is that it girl? That everything went really well, girl. Oh, this one is speaker. Very good. අතර ගෙදරින් ගාලා එලවන්නම දෙන්න. Then Mr. Prabhat Galagamage would come and just slam you. කවුද මොකක්ද ඔය කරන්නේ බල ඉස්කෝලේ යවන්නේ ඕල්ටද නේ සස් මම එක ස්ක්‍රීන්ෂොට් එකක් ගාගෙන තියන්නේ ඔයාලා තාත්තට මට යවන්න දෙනවා oh this is your future daughter-in-law okay by the way we are going to start heat and thermodynamics now, right? So you wrote that, no? Temperature is just a kind of sensation saying like how hot or cold, that's what. But we don't have any specific organ to see temperature, measure temperature. We can't see it through our eyes, but we can just feel it. Touch, oh, sure. When you touch a certain hot one, when you touch something really cold, still you do the same thing. Why? If it is too cool, it may cause frostbite even. The coldest place on the earth, if you just pour boiling water from like 1 meter height, it will fall to the surface with making really ice in minus degree Celsius. So if you extend your fingers out there in the Antarctica, it will just immediately get frozen. So measuring temperature with your skin is not a good thing. So you can't actually measure. It's not advisable to you to say like how hot or how cold. Even it is not really good, not accurate. So you have to have something to measure that. So that's why there are things called objects and the things, whatever the stuff, come up with thermometric properties. What? Now, right, change of temperature is not measurable directly. It's not something measurable directly. It's not something measurable directly. We can't measure that directly. There are some thermometric properties. Write this in a new line. There are some thermometric properties which show according to the change of temperature. The change of temperature due to absorption of heat or release of heat energy. Now write a subtopic. මොකක්ද කිව්වේ කියලා මම මතක නැහැ. Can anybody just remind me what did I say? කිව්වා මතක කරලා දානවා මම කිසි දෙයක් මතක තියාගෙන ඉන්නේ නැහැ. What did I say? Lastly, what did I say? Brindavan, can you say? There are some thermometric properties which change according to change of temperature. According to change of temperature due to absorption or release of thermal energy, heat energy. Now write a small subtopic, very small subtopic, heat. The thermal energy stored in an object due to mean oscillation of particles. Mean oscillation. Let's see what would happen. So there are particles in all the matter count you find. So this matter, all the particles are vibrating at some kind of, now I will only mark 4 of these, some kind of its own radius like this. It will be just vibrating like this. Once you add more heat, adding heat, okay, what would happen to this one now? The particles will begin to vibrate in more space now, taking up more space. Quickly copy that, because particles can absorb more heat energy to this. So the vibrations may increase its radius. Now it vibrates in more space. Okay. Okay. Yes, effectively the amplitude of the vibration increase. You know what is amplitude now? Amplitude increase. It is in a simple harmonic motion actually. Kind of simple harmonic motion it performs. Yes. Increase. So this is how it is. Now write this in a new line. We are going to learn this thing back in very nearby future. That's called the waves of thermal exchange. Right? This, the heat energy can exchange from one object to another, along a gradient of temperature. Gradient. What the heck is this gradient? Right. Consider it like this is object A, this is B. Now tell me which one is having higher temperature. කෝකේද වැඩිම temperature එක තියෙන්නේ? Which one has the more temperature? Tell me. B, because the particles have more energy. So heat will flow from B to A. Okay, along a temperature gradient. It is like T1, this is T2. The gradient of temperature is delta T is equals to T2 minus T1. Because of this difference, it will begin to flow from higher one to the lower one. Say yes or yeah. Very good. අඩුම ගානේ මගේ අර මොකද මීටර ටිකවත් ඔය ගන්න අනේ සර් ඔය නම් කියන්න බෑ, you know, in that 1 year program හොඳට කතා කරන සෙට් එකක් ඉන්නේ. Word expands. I will, man, because that expansion is one of the part of our lesson, and also you will understand this thing more in latent heat part. latent heat part, that's in the calorimetry. Latent heat you will understand, as well as in terms of the thermal expansion of solids and liquids and gases, you will get to know. This is like a trailer for these lessons. Right. May then lesson eකට මේ ටික ඇති. Right. So right now this is enough. Oh yeah. Shall I guess? All right. This exchange of temperature, sorry, yeah, heat. This exchange of heat is just controlled by, carried out by, rather than controlled, carried out by 3 different methods. What are the 3 different methods? Now you know. Thermal conduction, thermal convection, and thermal radiation. මේ තුනම වෙන වෙනම ඉස්සරහා කතා කරන්න ඉන්න නිසා මම දැන් ඇදලා ගන්නෑ නම් තුන විතරයි දාන්න. So you have to write the only the 3 names. Firstly write thermal conduction, first point, thermal convection, and thermal radiation. ඇති හොඳටම ඇති. I am the one telling you, no, just write that, more than enough. So thermal conduction is something like this. Again, that making momentum විතරයි වෙන්නන්න පුළුවන් කිව්වොත් ඒක අබූරුයි. See, now I hit this one, so it transfer the energy from this one to here, this one transfer to there, this one transfer to the other, the last one transfer to this one. So the momentum and the energy transferred from one object to the other. So that is why, see, actually all the particles included, this directly interact with this, see, the momentum and the energy, the force, everything is just transferred from one particle to other. So might be I'm the only one demonstrating heat using this gadget, but everybody use this one to demonstrate momentum only. Actually we can use this one to demonstrate thermal conduction very easily. Okay, from particle to particle. I will explain you that in the thermal conduction lesson, not now. Okay, now when one object is facilitated, to transfer its heat to another, when one object is facilitated to transfer its energy from one object to another, these two objects are said to be what? In thermal what? In thermal thermally contacted. So sorry, in thermally contacted. Thermally contacted. By any means, no? So in the terms of conduction, A to B, it will definitely have to physically contact as well. Definitely, it has to physically contact. Yes, of course. But now imagine A is there, is super red hot. So you keep B just above it. It will transfer heat by means of what? Convection. මේක නිකන් අර සූරමප්පා එකේ ගිම්බප්පා වගේ සීන් එකක් තියෙනවානේ. Thermal convection, is that physically connected now, contacted? Not physically in touch with each other, but thermally contact. Why? This one can transfer heat from here to there by means of convection. Okay, now it doesn't actually need to have physically in touch, but it's still thermally contacted. Okay, now you keep one object here, A, another one here, B. in a certain glass cage, no heat can escape, only transfer between these. Temperature is very high. Now it is not conduction, now it is not convection either, but through radiation it is in contact. Contact means not physically touching, but heat energy exchanges fairly well. So it is said to be thermally contacted. Thermally contacted කියන්නේ මෙහෙම අතින් අල්ලනවා වගේ මෙහෙම අල්ලන්න ඕන වෙන්නේ නෑ. It is like an LDR, long distance relationship. අහලා තියෙනවනේ එහෙම මේවනේ. Never see each other, never get the chance to contact with each other, but having a really good spiritual bond within them. එහෙම ඒවා තියෙනවා. So intermediate one is mobile radiation. Light independent resistor. You will get to know about thermistor as well. Thermally controlled resistor. Today, not today in this lesson, thermistor. Wanna not take care of that. LDR, long distance resistor. But really love each other. Sometimes they haven't seen each other even, but through the mobile phone and so some way, really connections. Okay. How do we get here? From A to B, it is like clearly radiating energy. Thermally contact. Write this in a new line. Thermally contact doesn't mean it is physically in touch. Thermally contact doesn't mean we are going to argue and that is bad. What is bad? What is bad means LDR. Are you debating about LDR is bad? Or what? Or mobile phone is bad, whatever. What is bad and what is your topic? Because I can give you so much of information about all of these because I am a debate champion, really, amma. Because I used to train many teams for debates. Easily, bang, debate එක train කරන්න පුළුවන් අනිත් මිනිස්සු ජීවිතේට දකින්න නැති. LDR no one is trustworthy. ස්වරයකට හොඳ බූටක් කාලාද කොහෙද? No one is trustworthy, LDR. Internet is corrupting youth. 1.4. So are you just kind of like supporting the idea or opposing party in that one? Or is that about toss? Toss gives you the side to choose whatever at the instant. You are the guys proposing about it is good or bad. Proposing about good or bad. You say bad. Then I think natural and the topic Okay, by the way. If you need, just ask me. I will give you more tips. Okay, by the way, I am going to erase. So, like this, thermally contacted doesn't mean it is physically in contact. Physically in contact කියලා. But still have a way to transfer heat energy. Now we are going to learn something really cool. For the first time, laws of thermodynamics. Actually, we already know what is first law of thermodynamics. That is the amount of conservation of energy. But this is a different thing. Zeroth law of thermodynamics. Friday. Zeroth law of thermodynamics. Zeroth law of thermodynamics. Other. Now, right? when two objects A and B thermally contacted and at equilibrium such there is no net flow of heat. There is no such net flow of heat between A and B. From A to B, it transfer, imagine like it sends some 10 joule, this sends 10 joule back. This gets 10 joule, sends 10 joule back. 10 joule goes, 10 joule coming. 10 joule goes, 10 joule coming. So there is no net exchange of heat. Can you understand this concept? Mami කිව්ව කතාව තේරුණාද? Say yes if yes. කියන්න. Oh my god. Very bad. කියන්න. Understood. Only Sas understood, others don't. I think only Sas is the only one student in this class who understood it, others don't. Oh my god, very bad. So how sad. Now it is about, now right, and B is thermally contacted with, now the second part of the story, B is thermally contacted with C and in an equilibrium of heat. Oh, මාර scene එක. මෙයා 10ක් ගන්නවා plus 10 minus 10 balance. This gives plus 5 minus 5. ඒත් කමක් නැහැ දෙන ගානම ගන්නවා. So it is in thermally contacted and equilibrium. මෙයත් එක්කත් පොඩි cross connection එකක් තියන් යනවා. This is like a girl having contact with a boy, and the girl is again in a contact with another boy. මාරදීන්නේ දැන් මේ ටික explain කරද්දී. But she doesn't know one thing. These two boys are really good friends since childhood. They also share the information. This guy sends photo of his girlfriend. Meanwhile, this guy sends him the photo of this is my girlfriend. They say the thing similar time. Wow. In the meantime, see, hey, Masham, me magi chellage photo ekak ne. The other guy also said, Masham, me magi chellage photo ekak. But same girl separated between two boys. How sad. Try කරලා බලන්න. ගුටි කන්න පුළුවන් වෙයි. Can you understand? Now they like, as a result, A is in thermally contacted with C in an equilibrium. මෙයයි තියෙනවා නම් මේ දෙන්නත් automatically connect වෙනවා කියලා කියන්නේ. It is like 6 gone to there, 6 released there. Example only, yeah. So somehow they are, all three are in a physically, thermodynamically equilibrium. Other කියන්නේ no net flow. එකකින් නම් කොහෙටවත් යන්නේ නැහැ. තේරුම් නැත්තම් නැහැ කියන්න කියලා දෙන්න. මේක තේරුම් නැත්තම් අහන්න. If you don't understand, because this one will define your future of thermal physics. ඔයාලා triangle එක තේරුම් නැත්තම් බඩුම තමයි. අහන්න කියලා දෙන්න. Imagine like this one is red hot on the tamaratu. This is really cool. This one is somewhat cooler. So now what you do, you just let this one to in contact with this rapidly give heat, this one rapidly getting heat. Somehow all of these two coming back to certain common temperature. This one also comes to certain common temperature. Imagine like it was 100 degree, like 10 degree, 30 degree. Now it comes to common temperature of 50 degree. This one is 50, this one is 50, this one is 50. Now all three are in contact. But in 50 degree means no heat flow from one object to another. Why? They are in equilibrium. I told you, no? It is like this. If this one is filled with water, like this, and there is a tap here, you can open. There is the water limit is this much. If you just turn this tap on, water will begin to flow from here to the other side and come to equilibrium. Now the tap is kept opening. Tap එක ඇරලා තියෙන්නේ. දැන් කොහෙටවත් යන්න විදියක් නැහැ. Finally came to some same height. Now there is no net flow. කොහෙටවත් යන්නේ නැහැ. Can you understand? අන්න ඒ වගේ scene එකක් වෙනවා. මේ හැමෝගෙම temperature එක equal. There is no way to flow now. හරිද? හා කියලා බබා මම පව් කියලා හිතන්නේ නැද්ද? Okay. Very good girl. අරගෙන මෙව නම් ඕනේ නැහැ. No net flow. No net flow. කොහෙටවත් වෙනම විශේෂයෙන් ගලන්නේ නැහැ equal. හානේ write this in a new line. According to exchange of temperature, there are some significant changes in matter. There are some significant changes in matter that can be measured in specific ways. In specific ways can be used in measurement of temperature. Temperature එක මානේ ඉන්න අපිට පාවිච්චි කරන්න පුළුවන් කියලා කියනවා. අපි බලමු ඇත්තද කියන්නේ කියලා. අපි බලමු. Let's see guys. Okay. Let me erase this. Write this in a new line. Thermometric properties. හරි. දැන් පොඩි ළමෙක් ඉන්නවා. You just slightly slap. Then the baby may just slightly slap you. Then you do what? Slap a little bit harder. Then the baby will slap you with very frowny eyes. Then you slap a little bit harder. Then about to cry. Then he just keep hitting you. Then finally you slap a little bit harder. Then the baby will cry. So, according to your slap, baby reacts. Like of the same way, different physical quantities, different matter behave differently as it get temperature, heat. So there are some visible things, there are some invisible things, but measurable in other means. වෙන වෙන ක්‍රම වලින් මැනගන්න පුළුවන් ක්‍රම එනට තියෙනවා. Okay. මං කියන්න දේ මොනවද කියලා. One thing is expansion of a liquid column. Write these thermometric properties. Number one, expansion of a liquid column with temperature. ඔයාලා දැකලා තියෙනව නේද මේ thermometer එක නිකන් it fills up with a certain liquid here. This liquid can expand. So under T1 temperature, when you heat it up to some temperature of T2, it will begin to rise like this. Okay. Change of expansion of a liquid column at T2. You can draw this if you want. Now write change of pressure of a fixed volume of a fixed mass of gas. Fixed mass of gas. එයා තමයි මෙයා. This is a rubber tube. This is a like a round bottle flask. You just like a flask, like very big glass container. There is a rubber tube. It is filled up with mercury. So now it is completely removed from all the labs because mercury is really harmful. Large quantity of mercury is not allowed now. Large quantity, but small quantities are still allowed. You can measure the change of height because this rubber tube can be bent accordingly. So it is something like this. Rubber tube එකම පල්ලෙහාට වැටලා තියෙනවා මේක. Let me get the bigger one. It's like this. From here, you can just raise until you to adjust the height. මේකයි එක ගන්නට එනකම් height එක change කරන්න ඕනේ. Now, according to the temperature, when the temperature changes, there will be certain pressure occur. According to this pressure, it will just push this gas sample back. Sorry, liquid column down. So you to bring that liquid column to this level. So by adjusting the other side, so you can measure the change of height. According to the change of height, it is just kind of like calibrated to measure the temperature. There is another thing, Galilean kind of like a thermometer. Galilean thermometer, that's not in our syllabus, but there is a higher possibility for you to get that in a paragraph essay because very recently in Edexcel A level they gave, that is not even in their syllabus, but it gave. So our system is always copying the Edexcel system, derive questions from there, so you have a higher chance to get that type of question from a Galilean thermometer. So better to search this in YouTube. Galileo Galilei, that's why its name is Galilean thermometer. Not in our syllabus, but you can search for your extra knowledge. If certain question came in from there, මම ගිය අවුරුද්දේ බූරුවන්ට කිව්වා ළමයි in Edexcel system now local A level is also trying to advance to the knowledge level of Edexcel. So you would better search these things like cyclotron and linear acceleration, accelerators, and those things because that's the modern physics. Just watch them because I don't have time to teach you. And one of the paragraph type of essay came in the last years considering about linear accelerator. ඒකෙම උත්තර ටික තියෙනවා. නමුත් වේලාසනින් බලන් හිටපු එකෙට ඇස් වහගෙන ලියන්න තියෙනවා. අපරාධේ. දැන් ප්‍රශ්න දෙන්නේ පුරුදු දේවල් වලින්ම නෙමෙයි. There are some equations you have never seen. The first time you see that in the paper, you have to apply. මම ඔක අට ගන්නනම් කියනවා. අපේ උන්ට ඉතින් අර ගිරාපෝතකයෝ වගේ උගන්වන සර්ලා සෙට් එකක් ඉන්නවනේ. උම තමයි ලොකු. equations ටික කට්ට පාඩම් කරනවා. ඔවා කරලා ඇඳලා කරලා අම්මා දෙයියන්ගේ පීඩයි ගිය අවුරුද්දේ ටර්ම් මොකද දුන්නනේ. පේපර් එක නිකන් සෙකන්ඩ් පේපර් එක එහෙම ඇඹරිලාම යන්නේ. අර easy physics උගන්වන සෙට් එක මොටිවේෂන් පාර ගහලා කටපාඩම් කරවල යවනවා. අපි ඉංග්‍රීසි මීඩියම් වුණත් යනවා සිංහල මීඩියම් පන්ති වල. ලෝකයි තියෙන ලොකුම ආදරලෙක්. ගිහලා අරුගේ මොටිවේෂන් අහගෙන ඉන්නවා. පැය 44ක් විතර මොටිවේට් කරනවා. මොටිවේෂන් කියන්නේ කෙනෙක්ට තව කෙනෙක්ට දෙන්න බෑ ළමයි. You have to motivate yourself. We can only guide you. මෙම motivation කියලා දෙයක් තියෙනවා ඕනනම් ගනින් කියලා guide කරන්න පුළුවන්. But nobody can motivate the other. Motivation comes from inside. ඒකයි වෙන්න ඕනේ. මම ඒකනේ සාමාන්‍යයෙන් ඔය life lessons වලට වැඩිය දෙන්නේ නැති ඒත් තේරුම් ගන්න. හොඳම life lesson එක තමයි මම උගන්වන lesson එක. හිතට කරලා ඔළුවට දීලා යන්නේ. So, and guide you how to gain some marks, how to search in the internet, and sometimes time to time just guide you. දැන් මොකද කරන්නේ කෙලවගෙන තින්නේ කොහෙද අවුල් කරන්නේ? ඇයි අවුල්? ජීවිතේ ගොඩ යන්න පුළුවන් මේක විතරයි කියලා වගේ මතක් කරලා දෙන එක විතරයි මට කරන්න පුළුවන්. Nothing else. Okay. This is another variable. Now, right, there are now the system is really changed. I told you, you can't use so much of stuff. So there is a thing using a flask, just a conical flask, and there is a rubber boom. And it is completely covered with wax. This is the new model, but new model couldn't be used in so far because COVID and terrorism attack all came in normally. So the school system is still trying to adjust. Still they are like under in the COVID period. ලංකාවනේ කොල්ලෝ දන්නවනේ. පිටක් විතර අවුල් රටක්. පාරවල බස් දුවන්නේ නැහැ. කොරෝනා කාලේ නතර වෙච්චා. ඉන්න තාම කොරෝනා. මොකද වෘත්තීය සමිති කියලා පොඩි සීන් එකක් තියෙනවනේ. ඔය වගේ දේවල් එක්ක පොඩ්ඩක් අමරටකම තියෙනවා. මේ පොඩ්ඩක් එයාලගේ වාසියට විතරක් තියාගන්න සීන් එකක් තියෙනවා. This is the new model. For what? A fixed volume thermometer. This is the new model. It is completely air sealed. So once the temperature change, it's trying to get expanded, but it is just restricted by this. But the dial will just rotate and show you the temperature. මේකත් අඳගන්න new model of this, new version of this. ඔය ජීවිතේ දැකලා නැති වුණාට paper වලට එකපාරට එයි. Now, right, change of volume of fixed mass of gas, change of volume of a fixed mass of gas under constant temperature, constant pressure. It is the Charles law. You will get to know. This part is sealed. There is a small amount of but mercury පොඩ්ඩක් පාවිච්චි කරන්න ඉඩ දෙනවා. චුට්ටක් පාවිච්චි කරන්න දෙනවා. පොඩ්ඩක් පාවිච්චි කරන්න දෙන්නේ small mercury drop. Small mercury drop. It can change the height like this. This is what actually change of volume. So the pressure is open. That means atmospheric pressure pi is maintained all the time. According to temperature change of temperature, it will change the height. That means in the volume in terms of height, because you consider like the area didn't change, only the height changed. So you can measure the temperature. ඒක වෙන්නේ කොහොමද කියලා හිතා ගන්න අමාරුයි නම් පොඩි YouTube පාරක් ගාලා බලන්න. මේවා එකින් එක කියලා දෙන්න කිව්වොත් දවසම යනවා. මේක මෙච්චරක් මේක මතකයි නම් එච්චරයි. If you can remember this, that's the only thing you need. If you can't imagine how that happened. ජීවිතේට අර මේ ටියුබ් එකක් අස්සට මේ පිස්ටන් එකක් දාලා මූව් කරලා බලලා නැහැ. අඩුම ගානේ you have never tried to see the mechanism of injection syringe. The one. See, now this liquid drop, see, it can change according to like this type of what scale. According to the position, you can read the reading over here. No, that is the directly volume, but this one is marked with temperature. You can read the amount of what position now. ඔයාගේ පොඩි සීන් එකක් තියෙනවා. මේ වගේ එකක් අද මූව් කරලා බලමු නැති එකට ඔය එකපාරට හිතා ගන්න බෑ. යකෝ මේක උඩ යන්නේ කොහොමද කියලා. යනවා යන්න පුළුවන්. Right. This is one of the method. So you can write another thing. Change of potential due to change of temperature in a thermocouple. In a thermocouple. මොකක්ද ඔය couple එක නේ? Thermocouple. It's like copper stuff, and you have the millivolt meter or microvolt meter, and the other end is just fixed. You maintain this at the melting ice. Melting ice means, you know the temperature in melting ice. What is it? Melting ice, not molten. Molten means water, no? Ice. What is the ice melting temperature? Or ice freezing temperature and melting temperature are the same. Yeah? Maintained at 0 degree Celsius. This at any other temperature of theta. So you can read this one in terms of potential difference. දැන් හිතනවා ඇති කොහොමද වෙන්නේ කියලා. Yeah, 273.1 Kelvin. මේක සාමාන්‍ය සෙල්සියස් වලින් ගන්නේ. So why this? Now you know one thing. Once something got hidden, you know the particles begin to move faster. Here in the junction, copper and titanium type of junction, different metals are used. An example here, there is the difference of what? Mobility of the electrons. These electrons will begin to flow faster. This one is a common wire. Now this one will let electrons move faster. Here the mobility is slower. The electrons from this wire to this wire comes along. This one is like intermediate to balance it. Somehow, according to that, there will be a flow of electron. That means a flow of current. According to that, there will be a change of potential between these 2 points. Because if there is a change of potential, only there is a flow of current. My God, you know, a thermocouple peltier එක. අද එක මට set කරන්න අමතක වුණා. In the next week, I will try to fix it. In the peltier, I have to fix it in a voltmeter. And one side I have to keep it in ice. At the other side, I have to find out the lighter. Light එකක් හොයාගන්න නෑ, හොයාගන්න ඕනේ. So when I hit the other side by lighter, you will see change of reading on the multimeter. Multimeter means the voltmeter. I can just fix the multimeter to voltmeter reading, then and read that. ඔයාලට බලා ගන්න පුළුවන් ඒ දේ. Okay. මම හිතනවා ඔයාලට තේරෙන්නේ නැති කියලා. This about thermocouple. So the last thing is change of resistance in a thermistor. change of resistance in a thermistor. Oh, digital that is something like this. You have a thermistor. There is a certain probe there. Using this probe, you can just put that in the stuff. There is a digital screen. On the digital screen, you can read thermistor. Hari. Anna properties ටික අපි දැනගත්තා. තව ගොඩක් දේවල් තියෙනවා. Apart from this, there are something like change of color. වගේ දේවලුත් තියෙනවා. හරි. මම වතුර ටිකක් තාර ගාලා දීලා ඉන්නම්. උගල ගේන්න වගේ. ඔයාලා රැක් ගාලා රීඩ් කරගන්න. Okay? Understand? Other again. Now right. Speciality in thermometric properties. There should be some specific thermometric properties. Specificity of thermodynamic properties, thermometric properties. Oh, what are the specificities? ඇයි මං ඔය specificity කියන්නේ? Why should it be more specific? Why? The reason is, first thing, specific features of thermodynamic properties. It should be what? A continuous variable. Okay? Continuous function of variable. Continuously වෙනස් වෙන්න ඕනේ. If the property is something like theta, change of temperature, versus the property x, if it is something like this, වෙලාවකට වෙනවා, වෙලාවකට වෙන්නේ. In Sinhalese, there was a certain teledrama. In the teledrama, I can't remember who was the actor. Like, might be, can't remember his name, but he said like, "Vidak khamati, vidak agamati, khamati akamati." Yeah, that means one time the girl seems to be liking him, the other time does not. It's like toss and fro thingy. So somehow, if it is like this, definitely it is not suitable. So the property should be straight. This is not suitable. If this is the variable, it is suitable. If this is the variable, like so, dropping, it doesn't matter. Continuously drop, it doesn't matter. Oh, go. Rather than the cross sector. If it is like declining like this, still suitable. මෙහෙම තිබුණත් ඒක suitable. In a kind of like what? Exponential decay. No problem. Mathematically, we can convert it in a scale. there is no problem because exponential constants are easily calculated. මේ හතර වෙන වෙනම හතරක් අඳින්නමයි කියනකට you have to draw these four separately. These type of discrete ones are not accepted. ඒ වගේ ඒවා ගන්නෙ නෑ. So if you have a kind of like friend, at least like a friend, girlfriend, boyfriend, someone who close to you has some fluctuating mindset, just drop him or her. Fluctuate වෙන මිනිස්සුත් එක්ක ගමනක් යන්න. Should be steady, firm. If they fluctuate, යාළුවෙක් වුණත් එක වෙලාවකට මං ඉන්නවා එක වෙලාවකට ඉනා වෙනවා එක වෙලාවකට බයිනවා ඉස්සු වෙකුනේ යාළුවෙක් හැටියට වස්තුනේ. Temperature measuring stuff, how can you read in between? No, you can't read. So then it is not suitable. But any other variability, accepted. Okay, copy it. The other thing, what is the other one? The variable should be having a function of singular result, having a function of singular result. මේ කතාව තේරුම් ගන්න පොඩ්ඩක් නියමයක් දෙන්න ඕනේ. Why? This is temperature, this is x variability. Right. Now imagine if you have a certain variable like this under t equals to specific t dash, you can have two readings. It's like x1 and x2. You get really confused. Oh my god, what is this temperature? You get like two results for the same temperature. That is not suitable. It gives you two results for the same temperature. Or this theta and x. Now it is like this. So the x dash will read temperature of theta 1 as well as temperature of theta 2. Very horrible. Horrible means absolutely horrible. You can't, because for temperature of theta 1 also it is x dash, for theta 2 also x dash. Not a singular result. Multiple results are given here. Not suitable, not suitable, not suitable. Okay. Now the next one is sensitivity of the variability should be really high. Imagine it like you have certain variability like this. One variability is like this. For certain temperature, it gives you very distinguishable x1 and x2. So from theta 1 to theta 2 gives a really good deviation. You can easily measure. Very good. But the problem is You might get another one. You can't see any distinguishable difference. This is not that suitable. Not that suitable. Because you can't take the values with sharp readings. Softly බලාගන්න බැහැ. Understand? Guys, can you understand? Yes or no? Hello? No කියන තේරුම් නැද්ද? Imagine. Okay. There are 3 students, right? 3 students. One is A, B, and C. A guy called D also with them. Now D say, bye macam, මං යනවා. They say, okay, bye. Then within like few minutes, they get a call saying that, Mashang, අපේ D met with an accident, he died. A would say, seriously? මේ දැන් විනාඩි 10 විතර ඉන්නේ බව අපිත් එක්ක කතා කරලා. B will act like this. Oh my god. Then they search for C. C is unconscious. They will have to spray some water and which guy is more sensitive now? A, B or C? Quickly. C. Sensitivity. For these ones, if you get widespread readings like this, you can read any value in between even. But if your readings are like this, for very big difference, it will show a very small limit. So the accuracy is not that high. Accuracy එක වැඩි කරගන්න නම් sensitivity එක වැඩි වෙන්නම ඕනේ. Other say yes. මේවා අහනවා structured වල ඒකයි මම මේ කියන්නේ කරගන්නකම්. Then the fourth property, right? Fourth property. What is the fourth property? Now just write. You don't like that. Okay. Should not absorb high amount of heat. Otherwise, it may cause errors. Imagine you are going to measure temperature of a small iron ball. Now you keep certain thermometer like this. What would happen is this one absorb more. This one absorb high amount of temperature, absorb more. It's not suitable. මෙයාගේ තියෙන්නේ පොඩ්ඩයි. ඒකෙන් ගොඩක් මෙයා absorb කරපුවම වෙනන්නේ 아무තු reading එක. It's not the real reading. Gives a false reading. හරිනේ? thermocouple එකක් වගේ තියෙනවා. අන්න edge එක. thermocouple. Absorb small amount. Suitable. චුට්ටයි ගන්නේ. චුට්ටක් ගන්න ඕනේ. That is suitable. Understand? The last thing is response rate should be higher. Then තියනවා class එක පටන් ගද්දී I'm just keeping this one to take the reading. Now it is almost halfway time is gone. Still I don't get a proper reading. That's not suitable. It should give the readings very quickly. Last property is response rate should be really high. මෙන්න මේ පහම set නම් එයා හොඳ thermometric property එකක්. හරි. then thermometers write this in a new line. Thermometers are used in measurement of temperature. In a readable manner. අපිට මේක read කරන්න පුළුවන් විදියකට convert කරලා දෙනවා. There are basically 5 types. I mentioned about all 5 types earlier. What is it? In the first one, it is called what? Alcoholic kind of what? Mercuric. What is it called? Thermometer. There is a bulb. It contains of like a fluid. That fluid is mercury. The mercury or kind of like (0°C to like 100°C. So it will expand from here. So you can read the amount of temperature over here because of the scale is there. There is a certain scale given. Right? This is the basic type. So I told you, I just gave you the not even, but not specifically. මේක එහෙම ලොකු note එකක් මම දීලා නැහැ. දෙනවා tube එකේ තියෙනවා බලා ගන්න. time එක save කරගන්න. මෙතන ඉන්න හැම ළමයාටම IQ එක හොඳයි. ඒක නිසා මම හිතනවා ඒක තේරුම් ගන්න පුළුවන්. The next type I also gave you, but constant volume, mass of gas with variable pressure. That gives you the temperature. I also let you to draw that diagram. The next one is constant pressure with variable volume thermometer. That one I also asked you to draw. And the next one is thermocouple. I explained you. The next one is thermistor. I explained you. And I included all the details in the tube. Please read it. Otherwise, I can read and just give you a note on that. So saying like why water is not suitable, because water is having some kind of difficulties, because from 0 to 4 there is a drop. Then again, it's called the ripple point. There is a change, but the thing is from 0 to 4 there is a drop. After that, increase. Somehow you can't measure anything below 0 because water freeze. And above 100, because above 100 it begins to boil. Not suitable. The scale is very lower expansion. The span is really low. Now in terms of like mercury, you can use it because there is a freezing point of about 39°C, minus 39, and plus 360 something. So the value range is really high. Okay. And the alcohol is also similar to that. So we use this alcohol and this stuff only for measuring of like what human body temperature and stuff. By the way, now I am going to take this one as a scale making. Now, right, to make a thermometer, it should have two specific points. Two specific points. Now tell me what are the two specific points? Number one, lower fixed point and higher fixed point. Lower fixed point, higher fixed point. Okay. For most of the cases, like this, for most of the cases, lower fixed point is considered as melting point of ice. Open a bracket and write freezing point of ice. So දෙකම එකයි යා water. Freezing point of water දෙකම අතන්දර එකයි. සාමාන්‍යයෙන් we take it like freezing point of melting point of ice. You keep your thermometer in melting ice. It just keep melting. You keep your thermometer and take the reading for whatever x naught. Whatever x naught. Okay, that is the lowest point of this thermometer. In this one, this is what lowest fixed point is 0 degrees Celsius. You mark that with the variable. What are the variability? It can be a certain pressure. It can be a certain volume. It can be a certain fixed voltage. It can be a certain fixed what? Resistance. There is a changing parameter. You take the changing parameter value. Imagine like it is giving you 20 millivolt. Example only 20 millivolt for 0 degrees Celsius. This is your lowest fixed point for thermocouple. Like that. If it gives you like 100 Pascal for pressure variable stuff, or like of a height change 10 centimeter for 0, whatever the value you measure is the lower fixed point. If you don't understand, please ask me. Now I am waiting only for 15 seconds. If you don't ask anything, I consider like you understood. 10 seconds more. 5 seconds more. Don't ask me. Lower fixed point, that is x naught. Now you keep that thermometer itself in boiling water. The boiling water. You know that this is the 100 Celsius. This is like higher fixed point. You mark that too. You mark that too. So this is your temperature scale. This is like x naught. This is like x higher. Now you can divide it in any way you would like. Imagine like someone, Sahas make his own temperature scale. What can Sahas do is, Sahas consider certain variable of something. You try that with the ice, melting ice. You mark the variability count. You again mark higher point at boiling, keeping it in the boiling water. and mark that change, and you divide that by certain specific number. Imagine like you divide it by 14 because that girl is just 14 years old. So, and make Sahas scale. It is just degree S. Yeah, it can be. Ne? Sahas 1, Sahas 2, Sahas 3, like that. Celsius, it is a scientist name. Fahrenheit, it is a scientist name. Kelvin, it is a scientist name. Sahas, it is also a scientist name. Right? You can do it. Sahas scale. You can make any scale. Now the problem is this theta is tallying with whatever the condition here, that is the variability. It can be a length, it can be a volume, it can be a color, it can be a kind of like a resistance, whatever it can be. Or a spring, you just hang a spring. කාට හරි හිතෙනවා ස්ප්‍රින්ග් එකක් පාවිච්චි කරලා ගේමක් ගන්න. හරි. අපි මෙහෙම ගමුකෝ. ඔයාලා මේ ඩයග්‍රෑම් අඳින්නද නේද මම මේ දුන්නේ ඔයා. දැන් ආයි කියන්න එපා මම මකලා ඉවරයි. I make something like this. Keep certain spring and just hang this in a certain like what? Weight. Certain weight here. So the weight of mg just downwards. So it will extend. So you supply heat using this type of ice cube. You just keep certain cable. It will transfer the heat to here. It will just extend to some initial value. You mark it. Then you do what? You keep the same probe to the boiling water and you mark the lowering of the this one. So what should you do? Now you measure the length and your range of temperature is there in terms of what? Weird thermometer. Thermometers කියන දේවල් අපිට හිතීච්ච විදියට හදින්න පුළුවන්. මෙහෙම එකක් දාලා ප්‍රශ්නයක් දුන්නොත් මොකද කරන්නේ? මාලා ගෙලියන්නේ නේ. You have to understand the concepts. Understand? So let me put that in a graph. Let me put that in a graph. Temperature and X. Have a really good look at. This is X naught. This is X highest. So and this is theta naught, 0 degrees Celsius. This is 100 degrees Celsius. Any other value, theta, any other value of X, you can mark it like this. Ne? So what can I get from there? The gradient is the same. What is the gradient I can take? X over Hx minus X naught equals to theta over 100 minus 0. So you can cross multiply and get whatever the value you want. එච්චරයි. එපමණයි සදා විශ්වාසයි. The same gradient it should be given by both. නේද? Say yes. Say yes if you understand. This ratio should be followed by the other ratio as well. Hurry. So shall we take an interval and come back? Or directly continue? කැමැත්තක් කියන්න. විනාඩි 10ක විතර ඉන්ටර්වල් එකක් ගන්නවද? ගමු ඉන්ටර්වල් එකක් විනාඩි 10ක. Take a big interval of 10 minutes. And let's get back